Hello students. In this video, we're going to delve into the concept of whether the matter around us is pure, a fundamental topic in chemistry that helps us understand the composition and behavior of different substances. Matter, the substance that makes up everything around us, can be classified into two broad categories: pure substances and mixtures. These classifications help us differentiate between substances based on their composition and properties. Let's begin by discussing pure substances. A pure substance consists of only one type of atom or molecule throughout its composition. This uniformity means that every sample of a pure substance will have the same properties and composition. Pure substances are further divided into elements and compounds. Elements are the simplest form of matter and consist of only one type of atom. For example, oxygen, hydrogen, and gold are all elements. They are the basic building blocks of matter and cannot be broken down into simpler substances through chemical reactions. Elements can be classified into metals, nonmetals, and metalloids based on their properties. Metals are typically shiny, malleable, ductile, and excellent conductors of heat and electricity. For instance, gold, iron, and copper are metals we encounter regularly. Nonmetals, on the other hand, are often brittle, lackluster, and are poor conductors of heat and electricity. Examples include oxygen and sulfur. Metalloids exhibit properties of both metals and nonmetals, making them unique and versatile. Silicon, for instance, is a metalloid used extensively in electronics due to its semiconducting properties. Compounds are pure substances formed when two or more different elements chemically combine in fixed proportions. A compound has properties distinct from the elements that compose it. For example, water is a compound made of hydrogen and oxygen. Even though hydrogen and oxygen are gases at room temperature, when they combine, they form water, a liquid with very different properties. Unlike mixtures, compounds require chemical methods, such as electrolysis, to be separated into their constituent elements. Now, let's move on to mixtures, which are combinations of two or more substances that retain their individual properties. Mixtures can be either homogeneous or heterogeneous. A homogeneous mixture, also known as a solution, has a uniform composition throughout. The substances within a homogeneous mixture are so evenly distributed that they appear as a single phase. For example, when you dissolve sugar in water, it forms a homogeneous mixture where the sugar particles are evenly spread throughout the water, making it impossible to distinguish the sugar from the water. In contrast, a heterogeneous mixture does not have a uniform composition, and the different substances can often be seen and separated easily. A common example is a mixture of sand and water, where the sand particles remain distinct and can settle at the bottom. Within heterogeneous mixtures, we can further distinguish between suspensions and colloids. Suspensions are mixtures where solid particles are dispersed in a liquid or gas but are large enough to settle over time. A classic example is muddy water, where the soil particles eventually settle at the bottom if left undisturbed. Colloids, on the other hand, have much smaller particles that remain evenly distributed and do not settle. Milk is a colloid where fat droplets are dispersed in water. One interesting phenomenon related to colloids is the Tyndall effect, where light is scattered by the particles in the colloid, making the light beam visible. You might have noticed this effect when sunlight streams through a dusty room or fog, making the light path visible. Understanding the properties of mixtures is crucial because it helps us in the separation of mixtures into their components. Various techniques are used depending on the nature of the mixture. For example, filtration is used to separate solid particles from a liquid, such as when filtering coffee grounds from brewed coffee. Distillation is another method that separates substances based on their boiling points, commonly used in purifying liquids like water or alcohol. Now, let's briefly discuss physical and chemical changes. A physical change involves a change in the physical state or appearance of a substance without altering its chemical composition. Examples include melting ice, boiling water, or dissolving sugar in water. These changes are usually reversible. In contrast, a chemical change results in the formation of one or more new substances with different chemical properties. This change involves breaking and forming chemical bonds, such as when iron rusts or when wood burns. Chemical changes are often irreversible, and they frequently involve energy changes in the form of heat or light. By recognizing the differences between elements, compounds, and mixtures, we gain insight into the composition and behavior of the materials that make up our world. Now, here's a question for you to test your knowledge. What do we call the process of separating a solid from a liquid by passing the mixture through a filter? Please share your answer in the comments. The complete curriculum for Class 9 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.